On this problem here, we're going to take a look at, if I have sine A, sine B, we're going to try and find the exact value of tangent A plus B. So if B is going to be between 0 and pi over 2, A is between pi over 2 and pi, so this means that B is going to be in quadrant 1. Here's my unit circle, 0, pi over 2, so that's quadrant 1. And then it says A is between pi over 2 and pi over 2 and pi right here, so that's quadrant 2. So I know that this is a positive quadrant. This one's going to be a negative positive. So my cosines are negative here, my sines are positive here. Alright, so given that information, we're going to go through and find the exact value of tangent A plus B. And I'm going to use that I know that tangent is going to be sine over cosine. Let's take a look. Starting here, I have that sine A is equal to 8 over 17. Now there's certain things I know about sine. I know that sine is going to be y over r. So y is equal to 8, r is equal to 17. Now there's an identity that I know also. I know that x squared plus y squared is equal to r squared. We were dealing with this the other day, and where r was always 1, so it was always x squared plus y squared is equal to 1. So, but these ones right here, my r is not going to be equal to 1 on this one. So I actually have to go through and try and find out what these are. So if I do some manipulating, so let's go through, subtract y squared from both sides, I get x squared equals r squared minus y squared. Square root both sides, so I get x is equal to the plus or minus square root of r squared minus y squared. So I'm going to use that to try and find my missing x. So I have the y, I have the r, I'm just missing the x to find the cosine here. So I'm going to have that x is equal to plus or minus the square root of 17 squared minus 8 squared. So 17 squared minus 8 squared is going to give me, let me see, that's 225. So 225, square root of 225 is going to be x is plus or minus 15. Now, I know from this right here it says that A is going to be in quadrant 2. I know quadrant 2 cosine is negative. So cosine x, or cosine A right here. So cosine is x over r, so it's negative 15 over 17. So I have the sine and I have the cosine for A. Now we have to do the same thing for B. So sine B is equal to 12 over 13. Y is 12, r is 13. So x is equal to plus or minus the square root of, same thing, so it's going to be 13 squared minus 12 squared, so that's going to give me 25. X equals plus or minus 5. And it says that B is in quadrant 1, and in quadrant 1 cosine is positive, so cosine of B is equal to positive 5 over 13. Alright, so I have all my values here, so now I'm going to plug in for my sine over cosine. So I'm stating that tangent A plus B is going to be equal to sine A plus B over cosine A plus B. Now I have to go back to my identities for this. So sine A plus B, let's write this out, sine A plus B is equal to sine A cosine B plus cosine A, sine B, over cosine A, cosine B, minus sine A, sine B. Now I have all that laid out, and go through and start plugging in the numbers that I have. So sine A is going to be, let's see, sine A is 8 over 17. Cosine B, 5 over 13. Plus cosine A, negative 15 over 17. Sine B, 12 over 13. Cosine A is negative 15 over 17. Cosine B, 5 over 13, minus sine A, 8 over 17. Sine B, 12 over 13. So I have a mess up here, so I'm going to multiply everything by the common denominator, which everything has a common denominator of 17 times 13. So that'll clear up everything. So I'm left with 8 times 5 plus a negative 15 times 12 over negative 15 times 5 minus 8 times 12. Okay, let's see what we get. Let's see, 8 times 5, that's going to be 40, and plus a negative, that's 150, 180, over, that's going to be 15 times 5, that is 75, negative 75, minus 96, that's going to be a negative 140 over negative 171. So my answer is going to be 140 over 171. And this is going to be my answer for my original question, which was tangent A plus tangent B. On this next problem, I'm going to prove that sine A plus B plus sine A minus B is equal to 2 sine A cosine B. So doing this, I'm going to go through and I'm going to use my identities, my angle addition identities. I'm going to write this out. Sine A plus B, so that's going to be sine A cosine B plus cosine A sine B plus, now we're adding this one, that's going to be sine A cosine B minus cosine A sine B. Now, looking at this, I'm going to go through and combine like terms. So right here, I have a positive cosine A sine B. This is a negative cosine A sine B. So those are going to cancel. So I have sine A cosine B, sine A cosine B. So if I have both of those, if I were to add those together, I'd be left with 2 sine A cosine B. So this one right here proves that it is equal to that. It's the same thing. When I add those together, those will go away. So I'm going to go with twice that one. On this next problem, I'm going to find the value of tangent x given sine x plus 30 is equal to 2 cosine x minus 30. So I have to go through and set this up. This is an equation here, so I'm going to go and find the value of tangent x from here. So let's go ahead and expand this. So this is going to give me, if I were to break it up, sine x cosine 30 plus next one's going to be cosine x sine 30 is equal to, now when I break this up, because the 2 is out front, 2 is a multiplier, so it's actually going to go in front of both terms. So 2 cosine x cosine 30 plus 2 sine x sine 30. Now let's go ahead and now that everything's plugged in, I'm going to go ahead and plug in my cosine 30. So I know those, cosine 30, sine 30, so I know that. So this is going to give me, cosine 30 is going to be square root of 3 over 2 sine x plus sine 30 is 1/2 cosine x equals, so if cosine 30 is square root of 3 over 2 and I have times 2 out front, the 2's will cancel, so I'm left with square root of 3 cosine x right there. And again, if sine 30 is 1/2, I have a 2 out front, the 2's will cancel, so I'm left with just plus sine x. Now let's move all of our sines to one side and all our cosines to the other. So if I were to move the sign this way, so I'd subtract that sign and I would add this. I'd subtract this one to go over here. I'm going to end up with square root of 3 over 2 sine x. So I'm going to subtract that one from both sides, so it's going to be minus sine x equals, so on this side I'm going to have square root of 3 cosine x, so I had to subtract this side to get it over here, so it's going to be minus 1/2 cosine x. Let's factor out the common sign, so it's sine x, and that's going to be square root of 3 over 2 minus 1 equals, now factor out the cosine. Cosine x is square root of 3 minus 1/2 over here. Now, what I'm going to do, I'm going to use the identity that I have, tangent is equal to sine over cosine. So I'm going to take this, I'm going to divide by this, both sides. So it's going to move it over here. I'm going to divide both sides by cosine. So I'm going to be left with So let's see. So I'm dividing both sides by this. So I should have on this side square root of 3 over 2 minus 1. Okay. Square root of 3 minus over 2 minus 1 right there. So those cancel. So I get sine x is equal to cosine x of radical 3 minus 1/2, and this one's going to be square root of 3 over 2 minus 1, and divide by cosine x both sides, so I should get sine x over cosine x, because if I'm dividing both sides by that, so those cancel. I'm left with let's see, square root of 3 minus 1/2 over radical 3 over 2 minus 1. Let's clean up that fraction, so multiply both sides by top and bottom by 2. So sine over cosine is my tangent x is equal to 2 radical 3 minus, the 2's will cancel, so I'm left with 1 over, 2's cancel again, radical 3 minus 2. And usually you don't leave a radical in the denominator here, but I went and checked the answer, and it actually does say that there is a radical left in that one. So that is my final answer on that. Now, here is the tangent formula. If you do want to use the tangent formula, but tangent formula is given that you already know the tangents of A and B. And on the unit circle, it actually doesn't give you the tangents. You only know the sine and cosine. So typically you want to just use sine and cosine and sine over cosine to be able to get your tangent. Otherwise you would have to know both of those. So you would actually take a lot more math using tangents in this problem right here. But you have a formula for it if you actually need to do the angle addition or angle subtraction for the tangents. Alright, page 73, my practice is 1 through 9, and the homework is going to be 1 through 4 and number 7. So that's actually going to be all. A couple of those in the homework actually have a couple different parts. So you could do all of those.